Hi. Woo! Yeah, that first microphone on thing always freaks me out. My talk's about Ruby alternatives. And first, though, I want to talk about Moore's Law. It's a law that I think Bob Moore or James Moore, or I don't know what his name is. He created, I think it was the 60s or 70s or some decade a long time ago. Essentially says that every 2 years, the speed of processors will get 2 times as fast. And the whole computer industry actually it was true, but then the computer industry even started following what he said and was like, okay, we're actually this is a good deal, we're gonna start doing this. So the computer industry followed Moore's Law. This is what Moore's Law looked like, I guess 2010, it's kind of an old chart, sorry. But you can see, I'm pointing up there, but it's a really wide room. The blue line is the interesting one. You can see around 2005, I think, it started to level off. The blue line is actually the clock speed, so the megahertz. So our processors stopped getting faster. And the reason why they stopped getting faster was because as they got smaller and smaller and smaller and smaller, the transistors, the wires between them, got smaller and smaller. And they're even saying that in the next few years or something, that these wires will be 10 atoms across, which is, like, just thinking about that super blows my mind. And as they got smaller and smaller, to avoid errors that were happening inside them, to be more secure about what was happening with them, the voltage needed to go up. And as the voltage went up, the wires got smaller, things started to kind of be hot and catch on fire and melt and things like that. So I was at Euroko 2015, and Mats gave a talk about how kind of the future of Ruby and what's going to happen. He talked a bit about the GIL or GIL or Global Interpreter Lock, and kind of what the future is of that. If you're not familiar with the Global Interpreter Lock, it makes Ruby our MRI version of Ruby, so only one thread can actually do something at the same time. So it can't actually be kind of the idea of parallel or all of these things happening at the exact same time. So he wants to get rid of the Global Interpreter Lock. But one of the main problems is that a lot of the C dependencies, the RubyC libraries, the extensions, kind of rely on the GIL existing. And threading is actually really, really hard. So he talked about maybe they're going to go with the actor pattern. They might go with, there was another one, dependency something. There's some wild stuff he was talking about. And the problem is that we live now in this kind of post-Moore world where our processes aren't getting faster. Our cores we're getting more and more cores, but our processors aren't actually getting faster. And this is what he said. I don't know if you can read this, but hopefully within this decade, we will take care of this problem in Ruby. So after the conference, someone came up to me. He's like, "Hey, what's up, dude? What do you think? What'd you think about Matt's keynote?" And I kind of overreacted a little bit. I was just like, you're not taking this into consideration? Like, this is really, really important, is what I was thinking. But after some time, I didn't pick up Elixir. I calmed down a bit, and so I'm cool now. I'm super relaxed. And this talk is going to be about kind of other things that are available. So I really like using Ruby, and I think that there's a lot of programming languages you can add to your stack to make your development process nicer, faster, whatever kind of problems you're trying to solve. So this is more about kind of learning new things and kind of expanding what you know based on these new things that you learn. So I'm going to cover a few programming languages, actually. I'm going to talk about Go, a little bit about Elixir, and then a programming language called Crystal. And if you were here last year, there was a whole talk about Crystal, which I should probably watch. This is going to be really, really kind of just basic stuff with each one, kind of an introduction to the programming language, some cool ideas with it, and a little bit of code for each thing. So I guess I'll talk about me real quick. This is my Twitter, my handle. And if kind of one of my meta goals for this conference is to have more followers than Ben, who's talking tomorrow. So if you're following Ben, can you stop following him and follow me, please? I'm one of the organizers for ROSConf, which stands for Ruby Open Source Software Conference. It's a traveling conference where we have maintainers of open source projects come and talk about their project in the morning, and then the whole afternoon we have a hackathon, and you get to sit next to people that are on the Ruby core team and work on Ruby with them, and other. Bundler was a project that we had. I'm thinking that we might do a tour of India in December or January, and if you want to organize a ROSConf where you live, talk to me, and we can talk about what you need to do to be able to organize one. They're super fun. I help startups. I kind of show them the right way to the right MVP, not creating this giant thing first, and then minimum viable product, fun startup words, woo! And then I also help Ruby freelancers kind of find more customers, and if you're a Ruby freelancer, come talk to me. I will help, maybe, probably. I'll help you. So, Golang is the first language we're going to talk about. Golang was created by Google. Google has a very specific kind of problem set. The first problem, the developer productivity was pretty low. The header files that they were using in their C++ code were getting super inefficient. If you include a bunch of things in different places, your compile time goes insane. The type systems that they're using in C++ and Java are just, they really get in your way. You have to really you're seeing it all the time. It's cumbersome. Garbage collection, they want because they feel, I think it leads also to developer productivity. And it's multi-core they want because Moore's Law stuff. So, some interesting features of Go is it compiles really, really fast. There's some smart caching that happens, but also compilation just is quick. The dependency model is much easier to deal with. You include a package, and if you don't use it, then the compiler freaks out. So it kind of is like, hey, what are you doing? You don't need that. So the type system is really easy to use. There's a lot of type inference that happens. So it of course doesn't feel as dynamic as Ruby, but it doesn't feel awful, like you're not forced into this sort of system. Has a garbage collector, which is actually, what is it, asynchronous now? They in the 1.7, I think, they made it so it does like crazy stuff. And and Go is actually really similar to object-oriented programming languages, though it is not an object-oriented programming language. I'm kind of sorry that side of the room. There's encapsulation that happens. Maybe I'll start over here now. There's encapsulation that happens, so if you have a package, lowercase stuff isn't available to the outside world, but uppercase stuff is. There's kind of a this self sort of situation when you create methods, like self and Ruby, constructors, methods on structs, mix-ins. You can embed structs, and then embed structs and those structs, and lots of embedding going on forever. And then there is interfaces, so kind of something that I think would be really nice in Ruby, actually. So the structs. Let's look at some structs and methods real quick. Here's some code. So this is me creating a struct. It's like a class. It has a name, member or attribute, and a slice of strings. So that's like an array. Here's a method on it. This R Rubius is what I meant by self. So self in this method would be R. That's an arrow for that. So this is the name of the method. If it's uppercase, then it's available to the outside world. Here's using just the standard. This is like puts. No, it's kind of like the percent operator in Ruby, if you've used that. And then we're using the strings package here to join the slice on commas. Woo! And every program needs a main function. That's what runs. And here we're creating a slice. We're creating a struct, and then we're calling a method. So it's really straightforward. It's not like you're not like, whoa, what is this? What's happening here? This is a crazy language. So with Go, there's the concurrency pattern that they use are Go routines and channels. So Go routine is a function that runs in the background. It would be kind of like doing like thread.new. And then a channel is something where you kind of communicate in between these different processes. It's very similar to like a Unix pipe. I have this kind of really basic example that actually really sucks. But I was trying to create, like Andy said, it's really hard to decide on the complexity of examples at a conference talk. So if you're interested in like a real hardcore example, not hardcore, I guess a harder core example than this, then come to me afterward and we can look at some code. But here, this is just like the extreme basics. We have a messages channel that we're creating. We're running this function in the background. That's what Go means. It says, run this in the background right now. It's sleeping, woo, for 1 second. Super exciting stuff. Then we send a string back through the message. So what will happen is this code will run before this ping thing comes through. And that's the big wow moment for this code. And when we have an arrow, that means like block on waiting for something to be available in this channel. And then we print a message. Woo! So yeah, please, if you're interested any more about like channels and doing crazy stuff with them, come and talk to me. But that's the best I can do right now. So practical use case. So if you want to start adding Go to your stack right now, you don't have to switch all of your code to Go. You can actually do kind of some of the processing work for if you're using Rescue or you're using Sidekick as a background queue. You can use Go as the thing that actually does the work. And there's this library that's available for Sidekick that it's a really super simple API to just plug it in on the other side of your Sidekick workers. So here I'll show a quick example of it. Our system, what does our system do? It sends emails and it transcodes videos. So here's our transcode worker. It does some magic stuff in the background. Here's send mail. You can see that it takes this message, this pointer to a message, which is a worker's message. That's where you get these arguments. So if you've used Sidekick or Rescue before, you send in a hash, or he was sending in YAML on the first talk, and you would send that in, and then you would have that available as this args on the worker's message. So you would just be, this is coming straight from your Ruby code to your Go code. Then you create this server. This is your server that's waiting for these jobs to come. And then you can say process emails from the emails queue with this send mail at a concurrency of 10. Process transcode at a concurrency of 20 with a transcode function. And then if you've used Sidekick or Rescue before, there's this web kind of UI thing that you also run. Here with this Go routine, you're creating this stat server in the background. So you actually have a web interface to look at what your Go jobs are doing. And then you just run it, and that blocks, and it just happens. That's your worker. You can do that on Heroku. It's good. It's easy. It's simple stuff. So I have arrows now. Whoop. Done with those. So I actually don't love Go. I think it's really cool. I think it feels like a tool to me, and like I've loved Ruby, and I don't feel any of the kind of emotions that I feel toward Ruby with Go. I'm trying to kind of get rid of some of those emotions with Ruby as well. But it feels like it feels like I know when it's the right tool for the job. It feels really like a tool. But I highly recommend just looking into it and checking it out. It's fun stuff. Lots of people hate the crap out of it, the way it handles errors, and it just looks like C. And, yeah. But there's other tools for you too, so whatever. Check it out. Look at it. So the next programming language I want to talk about is Elixir. Elixir is a programming language that runs on the Erlang VM. And Erlang is a programming language that was created in the 80s that solved a very, very specific problem. And the problem that Elixir solved was there were these so Ericsson created it, and they had this problem where they had these telephone switches, and they needed, if I make a call to someone and someone else makes a call to someone else, that if my call fails, that other person's call keeps going. Also that we can actually make these calls at the same time, and that we're not pausing like, oh, it's this call's turn, and we're pausing, because they're having hundreds of thousands, millions, whatever, of connections at the same time. So if you go, I have a link at the end of the talk. There's actually something called the Erlang movie. If you haven't watched it, I highly recommend it. It's really like nerds showing off nerdy stuff in the 80s that they're actually, like the thing that I just said with the telephone, they act that out, actually. Just they're like calling, hello, Bob. And he's like, hello. And it's good stuff. There's no dog in the actual one. Jose Valim, who is on the Rails core team, and he created Devise and a bunch of other stuff that you're probably using, he developed Elixir because he liked Erlang. He thought it was really amazing, but he really didn't like the syntax and some of the inconsistencies of it. So the goals were kind of to make this more consistent version. You're still using this VM that has these amazing concurrency patterns and all these really cool things, but with more of like a Ruby-like or more kind of a modern syntax. Some of the features of Elixir is it's a functional programming language, which is kind of like a messes with your head a bit when you're looking at it if you've never played with a functional programming language. It's Ruby-like. The syntax is very similar. It uses the actor pattern. There's concurrency up front, and it's fault tolerant. We can talk about that in a second, I guess. And there's a REPL. REPLs are great. That's one thing that I kind of like really don't like about Go is the kind of REPL stuff feels awkward. But there's a REPL. REPLs are fun. And it has a good standard library, so batteries included. So it's a functional programming language. All of the data is immutable. There is no when you are creating a new data structure, you don't change. Sorry, if you're changing a data structure, you don't actually change like a user's name. You would create a new version of the thing with the user's name different. That's kind of a very simple version of functional programming. This is something that Matt's also said. And this is one of the reasons that he also was thinking, I imagine, about using the actor pattern. And the actor pattern it's similar to this Go routine and channels, except you have all of these processes that you're creating, and you send these processes a message. So you'd have a swarm of things that were going on. Maybe you were sending emails. You would send like maybe the email address to each of these processes, and it would just take care of its own thing. They have metaphors like mailbox and things like that. So you have a process ID, you send it stuff, and these processes are all really, really, really super lightweight. So you can have millions and trillions and gazillions of them. As you can see, WhatsApp, probably familiar. I've heard lots of people saying WhatsApp, so it's probably used here quite a bit. They were excited in 2010 or 11 or something about having 1 million open connections on kind of a somewhat beefy server, or file handlers. They were handling this many kind of requests at the same time. And then in 2012, they were like, bah, that's nothing. Now we can do, what is this number? 2.3 million on one box. Woo! So it makes it possible to do kind of these things where you have a lot of open things happening at the same time, a lot of parallelism. Elixir is also fault tolerant. It uses these things called supervisor trees, where you have processes are doing some stuff, and then there's a supervisor tree that's watching them, and it says, oh, there was a failure here. How should I deal with that? Should I send the failure up the supervisor tree, or should I just kill that process and then maybe start up another one? And then that process has a supervisor tree that is like, should I throw away the whole program, or should I just throw away that thing? And that's part of the runtime. It's like part of the whole system. So it fits in. It's been tested since the 80s, so it's really secure. It's really nice stuff. But yeah. So I'm going to show a little bit of code right now. There's modules, which are very similar to a class also in Ruby, but I always mix up I always call these things methods, but they're actually functions. And so if I'm saying that, don't worry about the words I'm using. Just look at numbers and stuff. So this is a module that has functions on it, and it's pretty straightforward. It looks like Ruby, but there's a do. So Ruby do something. Here we're creating kind of a data object, a struct. It has a username, an email, login attempts, and default values, and that's how you create one at the bottom. And then here is kind of a more complicated example. We have a few things going on here. There is method overloading. We have pattern matching, and we also are calling out to Erlang. So you can see both of these methods have the same name. And the way that they are determined when you're calling this function is this thing in the curly braces is called a tuple, and this tuple has 3 members of it. So the first one is an atom. An atom is very similar to a symbol in Ruby. The next one doesn't matter what it is, and the next one doesn't matter what it is. So there's 3. It has to have 3 things. The first thing has to be an atom of rectangle, And then what it does is it binds the next two things to these variables inside of the function. So this is some crazy pattern matching in action. And it's like, it's super, at first you look at it and you're like, what's going on? What is this pattern matching stuff? But it starts to kind of come to you and you're like, wow, this is pretty neat. And like, I'm really excited about pattern matching. I think it's fun stuff. And here we have, this takes a tuple where the first atom is circle and then it has one other thing in it. And you can see that it binds that. And then we're calling out to Erlang here. It's really easy to call out to Erlang if you want to call out to Erlang all the time. You can do that. So you can see what happens if we send in something that doesn't match. Probably people in the back can't see, but it kind of freaks out and it says there's no matching. So it's saying we're trying to pattern match on this and we can't because there's no matching clause, so it explodes. A practical thing that you can do with Elixir right now, there's something that's been created called the Phoenix framework. And the Phoenix framework is kind of like Elixir's answer to Rails. It's very Railsy, but it's supposedly like magnitudes faster. It has some interesting ideas. It's worth playing around with. It's super interesting. I'm going to show some Phoenix code just to kind of give you a little look at it. Wow, that's probably small for some people. So here we have our scope, our base scope of the root URL, and then we have a get root URL inside of that goes to page controller index action. So really Rails-like. You can see that we're piping here through something called browser. And if you look up here, we have this browser stack. And the browser stack uses this thing called plug. Plug is really similar to rack. And these are kind of middlewares that it uses. So you can see with the browser pipeline that it accepts HTML, sets up your Flash session, things that you wouldn't need for a JSON API, for example. So that's why down here we have this scope for API, where we could also create an API pipe. So in the controller, this probably also looks really familiar. We have an index action, and we take the connection and some params, so any of the params that came from the HTTP request. This is super basic. We just render that with index.html, which is our template that we're using. So here we actually do some pattern matching with our attributes, with our params. So we're saying, I think I have some arrows. Yeah. So right here we have if the params hash has something that's called product, a key called product_ID, then we want to set product_ID as a variable inside this function, and then we can use it. So you can see we're using it here to get a product out of the repo. The repo it's just using SQL probably, but there's different kinds of adapters, or probably MongoDB actually in this case. So the render connection, we're doing that show template, and then we're sending the product into it. So that's like locals in Rails. So there's a bunch of other stuff. I couldn't really go into detail with the concurrency model. There's a lot of text processing stuff you can do. Meta programming, really Ruby-like. I didn't show error handling. There's a lot of macro action happening. But yeah, check it out. It's good stuff. It's interesting. Look at Phoenix. Install Elixir. Look at Phoenix. Like you can install Phoenix in a second and just start playing with it. Like from nothing to having something that was kind of doing a little bit of work took me very little time. So it should take you even less time probably. So I want to talk about Crystal now. So Crystal's kind of the new guy, the new kid on the block, and the reason that it exists is to solve some kind of problems that the developers had with Ruby. So with Ruby, a lot of the errors are happening at runtime. So this is kind of, if you have a compiler and it could catch it, it's really, really wonderful a lot of time. That's one thing like with Go that I really appreciate is usually when it runs, when it compiles, it actually works. And probably other people have different experiences with their Ruby code, but mine works less often than it should probably. Ruby is slow is what everyone yells. But as we just read in a recent article by DHH, that it isn't too slow. The deal is, this is kind of one of those questions of using the right tool for the job. So if you need something that is really fast, then you can reach for Go or for for Crystal, or if you need something that maybe the only developers that you can find anywhere are Ruby developers, like that's kind of really important. So maybe you stick with Ruby or PHP or anything like that. So it's really like find the right tool for the job, and if Ruby's fast enough for you, then you don't need this. But I mean, there's also a lot of other cool things with Crystal. So another problem is memory footprint. I'm quite surprised sometimes by the size of the amount of memory that my Ruby processes take. And then if I'm using something like Unicorn, then it's twice as much, or 3 times as much, or 4 times as much. And it starts to add up really, really fast. So some of Crystal's goals are to stay very, very Ruby-like. There is some static type stuff that you do, but they try and make it as light as possible. Yeah, so you should never have to say in a method what the type of the thing is. And that's the same point as before. The C bindings are pretty awesome. Like if you need to call out to any C code, it's very, very much like FFI, if you've ever used that before, but way nicer. And you're doing more kind of compile time like type inference stuff. You don't need to do a bunch of type inference or saying what your types are, like with Java, which gets kind of awful after a while. And it also should be fast and consume not a whole ton of memory. So some of the features are method overloading, like you just saw in Elixir. They're using Go's kind of model with, instead of Go routines, they have spawn, and then they're also using channels. There's a lot of type inference, static typing. The C bindings are wonderful. So here's an example of some Ruby code. It's very, very simple. It's a user class. I'm sure that you probably know what's happening there. So this is Ruby, but I can actually run this as a Crystal program, and I'm going to take a long time to actually do it in real life. So we're going to look at what it is. So I just actually ran that Ruby code as Crystal. It's amazing. It's really, really, it's the most amazing thing that you will see, I think, for the rest of the conference. So there's also, if you go to, if you're subscribed to Ruby Tapas, which I highly recommend because it's really, really, really good. There's a Crystal episode where he has a more, like, it's more code. It's a more of a complicated example of what, like, a Ruby program that he changes into Crystal. He has to do a couple of things to it. It's not just straight out. It doesn't just straight work. But you can see that there's just like, oh, maybe I have to give a type inference here or a type hint here, and then this, and then it just works. Like it's very, very Ruby-like. Something that you can use in Crystal right now, there's a framework, I guess it's a framework, called Kemal, which is very, very much like Sinatra. It's based on Sinatra. Here is some code. Here is a code for some, what is this? This is a chat server. This is all of the code that you need for a chat server. You can see this WS would be like the get or post or put or whatever for Sinatra, but its WS is for WebSockets. So this is just a WebSocket ready server that is a chat server, and we can look at the chat server actually going. This is Fatih and Serdar talking to each other. They like talking to each other on chat with Crystal, not on Crystal, but with Crystal, and it's that. And there's some React on the front end, which is something. So it's really everything. It will make your life easier. Everything will be faster. Those unicorns that you saw will actually exist. They'll fly around. It's great stuff. And what just recently happened was Mike Purnam. He is the creator of Sidekick. He just created a Sidekick version, or the worker version in Crystal. So if you want to, just like with the Go example I gave, you can start using Crystal today to be your workers on your app that you have, your really awesome app. So I don't recommend that really though, because it's really, really super alpha right now. It's like what we just looked. It's version 0.17.3. That's the latest one that I just downloaded. So I would recommend waiting around, but be aware of it. And since we have this, what is it, Minaswan, the Mats is nice, and so we are nice. This is actually a new one. It's Matt's donates to Crystal, and so we should donate to Crystal. And he actually, if you look at the Crystal donation thing, he's on there. He's got some good stuff going on with it. So as I said earlier, I'm trying to get further away from this and more into this. I want to kind of appreciate Ruby more as a tool and not as like part of my identity. And I think it's helping learning these other programming languages because it's just broadening my scope. If you want to learn any of these programming languages, Katrina Owen's project, Exorcism, is awesome. Exorcism.io. It's something where you get these kind of problems to solve in lots of different languages. You can pick your language, and you can go through step by step to solve different problems. There's tests already for you that you try and get the test to pass. And once they pass, then you can move on to the next step. And then the other cool thing about it is you can show your code, and then other people say, oh, you know, you could have maybe made that more efficient if you did this, or maybe this is a pattern that we use in Elixir and not this pattern. Especially when you're learning something as different as Elixir with this functional programming, it's nice to have people that have been doing it say, no, actually, this is a nicer way to do it. And people aren't mean. People aren't like, oh, this is awful, your code stinks. They're really like, people are super, super helpful. But check out exorcism.io. It's really, really neat. And thank you. And I'm waiting to get to like a conference where people are really into QR codes, and I imagine you're probably not because no one generally is. Does anyone actually use QR codes? Does anyone? No. Awesome. One day I will be in a country where people will get excited about QR codes. I think it's on the rise. QR codes are on the rise, guys. It's a new thing. So if you want to see the slides, if you want to link to the Erlang movie, which is one of the best movies of the 80s, check it out. And thank you. And yeah, peace out.
Thank you, Aaron. Maybe someone has have questions? Yeah.
Yeah. Does it work? Yeah, it does. Okay, how do you think, why does Go don't have classical class notion?
Well, I'm sure there's tons of answers for that from, they're very, very outspoken, the Go team. They like to kind of just, if you're like, I think that you should have generics in your language, they're like, they like kind of, like there's generally, they kind of, maybe they feel like they're too heavy. I can't remember. I actually, like, I swear that I've read it, but I don't remember why. But I swear that there's an answer somewhere on the internet for that. And if you don't want to ask a question, like the internet, like, or no, find me later and ask me. And if you want to look at that Go code too, it's really fun Go code to look at. Yeah, good stuff. Any more questions? What? Yeah, are we doing that?
Okay, I think not. Okay, thank you, Aaron. Great presentation.